Hi guys, it's me again, and today we'll continue talking about time. In my previous video, we spoke about time definition, and we concluded that there is no exact definition of time by any means. We also concluded that we have no idea what time really is when we talk about the nature of time. In many scientific topics, if you talk about the topic on a larger scale, there is a chance that you miss many details. But if you break it into smaller topics, let's say smaller portions of knowledge or information, you'll find that there are lots of opportunities that you may understand and have even new perspective related to that specific topic. Time is one of those topics. In fact, it's one of the most sophisticated and complex topics that science has yet to understand. The topic today is about time dilation and theories behind this let's say property of time, or proposed facts about time. Albert Einstein proposed that gravitational force may have effect on time. And let's be more specific, in particular about time passage, which means that time might be running slower or faster depending on the gravitational pull or gravitational force. Now, he proposed his theory a long time back when he also predicted the presence or the existence of black holes or the black holes. Scientists proved that there are black holes in the universe, and in fact the astrophysicists and the astronomers managed to take the first photos just some time ago of these enigmatic objects in the universe. Now let's go back to the time itself and what's the relation between time passage and gravitational pull, black holes, and etc. The theory says that for a person living on Earth, time passes as we all experience normal. But if it happens to be that you travel through the universe and end up living on a planet with stronger gravitational field, time will be different. Now, it says also that the stronger the gravity, the slower the time runs. And that explains sometimes on what we have seen in many movies, scientific movies or science fiction movies, about interstellar travel. And the most famous, or one of the most famous movies that we have watched several years ago is Interstellar, where it shows that when you travel nearby a black hole, because of the gravity strength, time runs in different notion or different speed. Let's put it in numbers. If you spend, for example, 1 hour near a black hole, that 1 hour equals 20 to 30 or 50 or whatever the years are on Earth years or Earth time. Now, this hasn't been proven scientifically. It's just a hypothesis or a theory yet to be proved by the scientists. However, there were many experiments that scientists did on Earth trying to prove that time dilation exists, because and time can be experienced differently, in different gravitational pull levels. One of the most famous experiments was the usage of the atomic clocks. The atomic clock is it's a clock that measures the variation of the radiation in an atom, which is very accurate. Let's say, for example, it measures time by the nanosecond, and the nanosecond is 1 billionth of a second. So the experiment went as follows. There were several atomic clocks placed in different altitudes. One of them was on the ground on Earth, and the other one was on a plane, on a higher altitude. So the higher altitude results in lower or less gravitational pull. So when they finished the experiment, they measured the time and they found that there is time difference between the clock that is placed on the ground on Earth and the other one which was on the plane. That gave them the conclusion that although this time difference is very, very insignificant, they said they needed much more space or like altitudes to measure more accurate information. But they concluded that this is a proof that yes, time can be affected by gravity. But hold on a minute. Let's go back to this experiment itself. When we say time, measuring time, first of all, there is a machine, whether it was an atomic clock or normal clock or whatever, to measure time. We created this thing or this machine to help us figure out how time runs or to calculate the passage of time. Now, when gravity increases, the effect, as a matter of fact, is on the machine itself, not on time. So basically, when the atomic clock was on Earth, on the ground, the gravitational pull was more on those subatomic particles that they use to measure time than the ones on the higher altitude. So basically, time itself was not affected. Let me put it this way: time itself is not affected at all. What was affected is the machine that we were measuring the time with or by. Regardless of its subatomic particles or whatsoever, it doesn't matter how small or insignificant that material is. It's still a material that is affected by gravity. But time itself, in my opinion, or my conclusion, let's say, of this experiment, was not affected at all. Now, the question is, if we don't really know what time is, how can we say, for example, it can slow down or can be faster? How do we know, for example, that the effect of gravity really makes things different? Yes, we saw many scientific movies showing that somebody went, let's say again the movie of this Interstellar, when the guy traveled through the stars and he ended up coming back younger than his own daughter. And why is that? Because he was experiencing time passage differently, closer to the black holes and the wormholes and the deep spaces of this universe. It's very interesting concept, it's very interesting fact if this is happening really. But again, this has not been proven scientifically as of this moment. All what we have is theories that says time might be affected by gravitational pull and etc. For the fact that human beings have never been further than the moon. Nobody has ever traveled to experience this theory. Now, will that happen in the future when we are able to travel in the speed of light? I'm not sure. But perhaps yes, because science is advancing all the time, and as we all know that what we know now is just a small fraction of what there is in the universe. Now, speaking of time itself, when you are feeling sad or you're feeling bored, you feel that time runs very slowly to you. While in fact, when you are happy or you are busy, let's say, or in different mode, you feel that time runs faster. Now the question is, what time has to do with emotion? Is it a physical entity or is it emotional entity? Now, if we say time, for example, passes very slowly for somebody who is not feeling really happy or like feeling down or like feeling bored, At the same time itself runs faster to somebody else, feels faster. Now again, what is it to do? Is time again an emotion or feeling of time that we feel? For example, somebody's happy, sad, etc. Is it an emotion, or is it the physical entity, like what we say, for example, in physics, as the fourth dimension, as Einstein proposed? Again, now this is one of the most complicated characteristics of time, or time, properties. So we leave these questions again for more in-depth meditation or thinking about how time runs. What is time? Is it really affected by gravity? Is it a physical entity, or is it an emotional entity? And now we get more, complex information or about time. I hope that you have enjoyed the video today, and that you found something intriguing about time, and that it has triggered more questions within you about the nature of this notion or this topic. We always say time, but it's really something that is sophisticated. And now, as we have seen in today's discussion or today's topic, time is really sophisticated, and it intersects with many things. And most importantly, that we spoke about emotions and the relation between emotions and time. And this is again, will raise many questions within us, and which will we also speak about in several videos to come. Thank you once again for watching, and see you next time.